Let us look at these two sets. We want to look at the equation that determines the number of elements in each set. Alright? Now, here. Set A contains A, B, let's see now. A, B, C, D, E, F, G. A, B, C, D, E, F, G. Alright. So the number of elements in set A equals, so how many do we have? 1, 2, 3, 4, 5, 6, 7. Okay. So we have 7 elements in A. What's the number of elements in B? What are the elements first of all? B is the set. What do we have? E, F, G, H, H, I. E, F, G, H, I. Okay. E, F, G, H, I. Alright. So the number of elements, let me fix this thing here. Number. This is number. Number of elements in set B is equal to, how many is it again? 1, 2, 3, 4, 5. 5 elements are in B. Okay, good. Now, the elements in A intersect B are what? A intersect B is the element, are the elements E, F, G. Okay, we see that. We have E, F, and G. Alright. What's the number of elements in set E, F, G? We have 3 of them. So that is equal to 3. Okay. Now, let's look at the number of elements in A union B. Oh, not number, just the set A union B. What is that set? Well, we have A, B, C, D, E, F, G, H, I. Okay. Everything. We have A, B, C, D, E, F. Let's continue down here instead of interfering with the number of F, G, H, I. Alright. So, there we are. What's the number of elements in A union B? Oh, but the way this kind of look like V, it should be more like this. Okay, A union B. What do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 elements in A union B. Alright? Now, here, let's see something. Now, the elements in A, B, A intersect B and A union B. If we count how many elements we have in A, or if we look at them, A, B, C, D, E, F, G. The elements in B, E, F, G, H, I. Now, here, we see that we mentioned E, we mentioned F, and we mentioned G. So if we should count the elements 1, 2, 3, 4, 5, 6, 7, then 1, 2, 3, 4, 5, 7 and 5. would be what? 12, not 9. But guess what? When we counted, we mentioned, when we were listing them, we had E repeated, we had F repeated, and we had G repeated. Alright? So we repeated those elements, E, F, and G. So we double counted E, F, and G. So we need to remove E, F, and G. Alright? In other words, if we say what's the number of elements in A union B, we would have to say, let me write the union sign again, union B, right? We would have to say it's 7 in A plus 5 in B. But being that we double counted E, F, and G, we have to remove them. So we have to minus 3. So therefore, what do we have? 7 and 5. This is equal to 12 minus 3 to give us the 9. Alright? So if we were listing them, we would list E 2 times, F 2 times, G 2 times. So when we're counting them, we counted E 2 times, F 2 times, G 2 times. So we have to remove them once. So therefore, here, in the formula, number of elements in A union B is equal to number of elements in A. So we see that is 7 plus the number of elements in B, that was 5. So we have the number of elements in A plus the number of elements in B. But when we had the number of elements in A, we mentioned this, these 3. Then the number of elements in B, we mention them again. Alright? So we have to remove them once. Remove them, the double count. Because when we're saying A, we had E, F, and G. When we're saying B, we have E, F, and G again. So we have to remove that double count. You subtract 3 from it. So we say minus, and that would be the number of elements in A intersect B. Alright, the intersection. We subtract that to get this equation. Number of elements in A union B is the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. So we use this example to show that this equation will work.